Okay, vectors. You maybe have seen this if you took an engineering course or physics. Um, Today is just a very basic introduction into vectors. And this is a vector. It kind of looks like a line segment, but it does have an arrow. It has an initial point of A and a terminal point of B. There's two important characteristics to vectors, and one is direction. I didn't write it down. I don't know why. We'll use an angle to represent the direction of a vector. And then there's also the magnitude of the vector, and that's the length of the vector. And then we can also add vectors, subtract vectors, do all sorts of cool things. So let's look at example 1. It says, given the following vector, draw examples of the following. If that's my vector, vector V, we'll call it. Isn't this like one of the criminals from Despicable Me? So negative V means that it's a vector of the same length, but it goes in the opposite direction. So that's negative V. 2V would be twice the length, but the same direction. 1/2 V, half the length, and negative 4V, be opposite direction, and say 4 times the length. That makes sense to everybody? So if we want to sketch examples of the following vectors, if this is vector A and that's vector B, we want to sketch negative A. We're simply going to go in the opposite direction, same length. And if we would like to sketch negative B, again, we would go in the opposite direction, the length of B. Suppose we wanted to add two vectors together, A plus B. Gabe? Okay, so what we can do is we take vector A, and then we take vector B, and we place it on the end of vector A. So we've traveled, or we have a force of vector A, and at the end we apply then vector B. And the resulting vector, whoop, the resulting vector is A plus B. So how would you draw A minus B? Yeah, I could take vector A, and then I'll attach onto vector A negative B. And so from my beginning spot, I have a resulting vector of A minus B. How would you do B minus A? Take vector B and you add on to it negative A. And so you get this resulting vector, which is B minus A. Are you all right? All right. We have horizontal components and vertical components to our vectors. So if you have vector v is equal to, and we use, instead of parentheses, we use kind of this, you know, arrow type thing. A is the horizontal component, B is the vertical component. And the way we would come up with it is if you're given 2 points, the horizontal component is x sub 2 minus x sub 1. And the vertical component is y sub 2 minus y sub 1. So you don't have to draw this every time. I'm just doing it for effect so you can understand what's actually happening with the mathematics. So if I plot point P over 3 and up 4, and I plot point Q, which is over 7 and up 5, you can see that between these two, I have a vector. Now, what I'm going to do is I'm going to write it in component form. In order to write it in component form, I subtract the x values. 7 minus 3, 4. 5 minus 4, that's the component form of the vector. Mathematically, what actually happened was we took this and we put its initial point at 0, 0. So you can see it's over 4 and it's up 1. Always start with the second x value. So that's what happened. Okay, does that make sense? This is, okay, so we started off with these 2 points. The vector was located between 2, but often in mathematics we like to put things back on the origin. All right, so when we subtracted these, what it did is it gave us a vector of 4, 1. So that means it would start at 0, 0, and it would go over 4 units and up 1 unit, which is what I have with my drawing right there, right? So that's all that's happening. Okay, let's look at this one. Okay, I won't draw the picture this time. We will simply write it in component form. 4 minus negative 3, 7. And negative 1 minus 2. So that's component form of your vector. Any questions? Okay, flip it over. The magnitude of the vector is the length. And the way that we find the magnitude of the vector is very similar to how you found the modulus of a complex number before. Yes? No. Just so you would understand what was happening. So we have the magnitude of v, which is equal to the square root of a squared plus b squared. The horizontal component squared plus the vertical component squared, and then you square root. That makes sense? The magnitude of the vectors. So I have the square root of what? 25 plus 4 or 29. So it's nothing that we learned today is all that difficult. It's just new. So yep. 0, 3, 3, 3, 4, 5. If you have a vector u, which is a1, b1, and you have a vector v, which is A2, B2. Then we want to look at the sum and difference of the vectors. If you want to take vector u plus or minus vector v, we would get a1 plus or minus a2, b1 plus or minus b2. Whoop. Yep, sorry. In ancient Greek, they didn't have the V sound. And right now their B sound makes the V sound. Who would know? Okay, so given A is 1, 3, and B is 2, -2, find the following. 3A. Anybody want to guess what it is? You would add up 3 of the A's. So you add up the horizontal parts. Then you add up 3 of the 3's. You add up the vertical parts. Or you can just distribute the 3 through and you get 3, 9. How about 4B? 8, -8. So if you take 3 and multiply 1, you get 3. And then take 3, multiply 3, you get 9. A plus 2B. We're going to take vector A, which is 1, 3. We add on to it 2B. What's 2B? 4, -4. So our sum and difference of vectors says that if you're adding them, simply add the horizontal components. If you're subtracting them, subtract the horizontal components. I'm going to add these together, so I do 1 plus 4 is 5, and 3 plus -4 is, so that's your vector. What is 2A? 2, 6. Minus, what's 5B? So we subtract them, 2 minus 10, and 6 minus -10. Can you do basic vector addition, subtraction, multiplication, stuff like that? Okay. Vectors in terms of I and J's. So don't ask me why, because I really don't have a good answer for you. But if you have a vector 3, 4, well, it can also be written this way. 3I plus 4J. I don't know why your book does that, and a number of the questions that you have either refer to I and J, but I don't know. They don't use it that way in physics, and I haven't seen a good explanation yet. Yep. That's it. Okay. Horizontal and vertical components of a vector. So if you have a vector that has horizontal components of A and vertical components of B, and an angle of theta, we can write an expression for the horizontal component, or A, and an expression for the vertical component, B. The magnitude of the vector we will write as absolute value of B. Anybody come up with a relationship using sine or cosine or tangent involving these pieces? Cosine of theta is equal to what? A over the absolute value of B. So I want to solve for the horizontal component, so I'm going to multiply both sides by the magnitude of V, and I get A is equal to magnitude of V times the cosine of theta. So if anybody ever asks what's the horizontal component, you could simply take magnitude of V times the cosine of theta, and you would get the horizontal component. Vertical component, we'll use sine. Sine of theta, B over the absolute value of B. And I get B is magnitude of V times the sine of theta. Any questions there? Yeah, I would. Any of the stuff that we're writing down as far as notes today that you don't think you're just going to remember, I would write those down on your sheet of paper that you get for notes. Nope, you just use a sheet of paper. 8.5 by 11. No poster boards. Hannah. Sure, go ahead. All right, it says express the following vectors in terms of I and j. And we'll just find the horizontal and vertical components, and we'll write it both ways so that you can understand. But so I would like to write a vector in the form of AB, so component form. So in order to figure out A, I take the magnitude of V, which is, it's the magnitude of V, 3, times the cosine of theta, or cosine of 30 degrees. Is there an exact value for cosine of 30? Yeah, it's the square root of 3 over 2. So we get 3 roots of 3 over 2. And then for B, what we have is 3 times the sine of theta. And theta is 30 degrees. Three times 1/2, 3 over 2. So you can see these two pieces. So what I'm going to do is I'm going to write it in component form. So I have 3 roots of 3 over 2, comma, 3 over 2. And then I will write it in terms of I and j. 3 roots of 3 over 2, I, plus 3 over 2j. So there are times that your book asks for this. I won't ask for this on the test. I just want you to understand so you can understand the assignment and how they're interpreting the answers in the back of the book. But this is what I'll be looking for. I and j. They might ask you to do in terms of I and j. They might also ask you to, given I and j, go the other direction, which is what we'll do next. Okay. All right, we look at the next one. Again, the horizontal component is A equals the magnitude of V, which is 4 times the cosine of theta. Is there an exact value for cosine of 315? Root of 2 over 2. 4 times the root of 2 over 2 gives me roots of 2. And then B equals 4 times the sine of 315. And the sine of 315 is negative root of 2 over 2. So we get negative 2 roots of 2. So that would be the exponent form. They ask for it in terms of I and j. 2 roots of 2I plus minus 2 roots of 2j. Question? Do you have a bad case in the Mondays? Every day. Wow. Uh-oh. Not much time left, right? I mean, we got 1, 2, 3, 4.5 weeks for seniors. Okay, find the magnitude and direction of the vector. The magnitude would be the absolute value. So the absolute value of the vector is equal to square root of b squared plus b squared, which is root of 5. Any idea how we find the direction? Think back to what we learned in 7.6. Okay, if it's positive or negative, we need to set up an equation. The equation starts with a trig function that starts with t. Tangent of theta, which we don't know, is equal to b divided by a. Hi, girls. Where is tangent negative? Very good, 2 and 4. Tangents negative in 2 and 4. Which quadrant are we working in if our vector is negative 1, 2? It's in the second quadrant. So let's inverse tangent of 2 on our calculator. We're going to work in degrees because for these applications, all the answers are in degrees. Mode. Yep. Somebody inverse tangent of 2. Okay, 63.43. If it's in the second quadrant, that would mean that theta is equal to 116.57 degrees. So it says the magnitude of the vector is equal to the square root of 5. The direction of the vector is 116.57 degrees. Yes. Here's what you're doing now. Yes. Okay, the next one, you can see that it's written in terms of I and j. I just write it like this. Root of 3 over 3, negative 1. So the magnitude of the vector is the square root of plus 1 Yep, 2 over the root of 3. 2 roots of 3 over 3. That's your magnitude. And now we find the direction. I set up tangent of theta is equal to b is negative 1 over 1 divided by root of 3 over 3. Multiply by the, and I get negative 3 over the root of 3, or negative 3 roots of 3 over 3, negative root of 3. You sure can. Where's tangent negative? Which quadrants? 2 and 4. Which quadrant am I working in this situation? fourth quadrant because my vector positive then negative. So fourth quadrant. I inverse the root of 3 and I get 60 degrees. So I can see I'm 60 degrees back of 360, which would be, so I know the magnitude of the vector is equal to 2 roots of 3 over 3, and I know that my angle is equal to 300 degrees. Okay, we'll do one more problem. We're not going to do 9. We're going to save that for Wednesday, but we will do 8 good application problem. A man pushes a lawnmower, and not the lawnmowers that you're used to pushing. Raise your hand if you use a riding lawnmower. Okay, good for you guys. Raise your hand if you use one that's self-propelled. You can at least, okay. Raise your hand if you actually have to push yours, like you have to push it. Raise your hand if you push one and it doesn't even have an engine. It just like spins around as you push it. And raise your hand if your parents or brother do it for you. Oh, okay. Okay. All right. So we're talking about a lawnmower that you actually push by hand that they would do the greens with on the golf course, okay? Right? Go to the golf course greens and they got to get those super sharp razors out on those super nice little lawnmowers. One year my parents decided they wanted to be totally eco-friendly, and so they got rid of the lawnmower that had, the gas engine, and they got a real old-fashioned push one. And it worked fine the first few times you did it, but then you got to continue to sharpen the blades. And if you don't, then it just gets snarled up. And we didn't use it the next year. So all right, so here we got Tyler Hendrickson going out to push his lawnmower. Okay, it's one of those lawnmowers, little shavings flying everywhere. Do some grass, and then the grass he hasn't cut yet will dry longer. Okay, cool. I guess the shaving should probably be green. Right? Bluegrass. Yeah. What? Oh, toaster on wheels. Interesting. See who gets in a link for this here. Okay, so well. Okay, 90 degrees, and so this is the vertical component, B, and this is the horizontal component, A. We know the angle formed between the ground and the handle is 40 degrees. And we know the force that he's pushing with, 24 pounds, is going to be the magnitude of the vector. So obviously, if he's pushing the lawnmower, some of that force is going down, some of it's going horizontally. We want to figure out how much force is being distributed in each direction. Okay? And so what we do is we simply set up the component pieces. A is equal to the absolute value of the vector times the cosine of the angle. So A is equal to, the magnitude of the vector is 24 times the cosine of 40 degrees. Is there an exact value for cosine of 40? No, so just type in your calculator, 24 times the cosine of 40 is pounds. Because your degree or your angle is given in degrees, that's your indication that you need to be in degrees. It doesn't say cosine inverse. And if you were given A and trying to find the angle, then you'd be doing cosine inverse. So cosine inverse is what we use when we try to find angles. We're not doing that. Okay. B is equal to 24 times the sine of 40 degrees. And 24 times the sine of 40 is? Okay. Got it? Okay, you said 2, so I'm leaving 2. So, there you go. Should have spoke up sooner. There you go. Your assignment. And I'll also make sure you have a study guide for tomorrow. Page 599, numbers 1 through 6, 17, 18, 23, and then 27 through 39, the odd. We have 10 minutes to work on it in class. Go.